Alright, so in this problem, I have 5 to the power of x is equal to 0. So, I obviously want to find the value of x here. So for my solution, well, I'm going to first start by, let's start by trying out values of x. So if I have 5 to the power of 1, for example, this is equal to 5, right? If I have 5 to the power of, let's do 1 less than 1, 0. Well, any number to the power of 0 is 1. If I have 5 to the power of negative 1, this is going to be 1/5. If I have 5 to the power of negative 2, this is going to be 1 over 25. Let's say I have 5 to the power of negative 10. This is going to be 1 over 5 to the power of 10. So you see, as the exponent keeps on decreasing and decreasing and decreasing, well, it's approaching infinity, right? But will it ever reach infinity? Well, let's see if we can even find a value of x that makes this equal to 0. So, the first step I'm going to do is take the log on both sides. So I have log 5 to the power of x is equal to log of 0. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. And I can move x here to the front. So now I have x times log 5 is equal to log 0. Now, if I divide both sides by log 5, these two cancel out, and I get x is equal to log 0 over log 5. Now log 5, this is equal to 0.6990, and log 0, this is actually undefined, meaning I have x is equal to undefined over 0.6990. Well, if something's undefined and you divide it by a number, it's still going to be undefined. So, meaning the value of x is undefined. Alright, so in this problem, I have m to the power of 3 plus m is equal to 350. So the first thing I'm going to do is subtract 350 on both sides. So these two cancel out, and now I have m to the power of 3 plus m minus 350 is equal to 0. Now, m to the power of 3 plus m minus 350, well, I can rewrite 350 here as negative 343 minus 7. So now I have m to the power of 3 minus 347 plus m minus 7 is equal to 0. Well, m to the power of 3 minus 347, this is the same thing as m to the power of 3 minus 7 to the power of 3. And I have this plus m minus 7. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is the same thing as a minus b times a squared plus ab plus b squared. So in this case, a is m and b is 7. So I have m minus 7 times m squared plus 7m plus 7 squared. I have this plus m minus 7 is equal to 0. Now, 7 squared, this is the same thing as 49, so I have m minus 7 times m squared plus 7m plus 49. plus m minus 7 is equal to 0. Now if I factor out m minus 7, I have m minus 7 times m squared plus 7m plus 49 plus 1, which is equal to 50. So this is equal to 0. So now this gives me two equations. I have m minus 7 is equal to 0, and I have m squared plus 7m plus 50 is equal to 0. So m minus 7 equals 0. This is the same thing as m equals 7, so this is already one solution of m. And m squared plus 7m plus 50, you have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the same thing as negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times a, which is 1, times c, which is 50. And if you notice, this is the same thing as the square root of 49 minus 200, which is going to be a negative number, meaning this won't work, and my only solution is m equals 7. Alright, so in this problem, I have 2 to the power of 1000 minus 2 to the power of 999. So to solve this, for my solution, first start with 2 to the power of 1000 minus 2 to the power of 999. Now, I'm going to rewrite 1000 here as 999 plus 1. So now I have 2 to the power of 999 plus 1 minus 2 to the power of 999. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 999 plus 1, that's going to equal 2 to the power of 999 times 2 to the power of 1. Now I have this minus 2 to the power of 999. Now this is the same thing as 2 to the power of 999 times 2 to the power of 999 times 2 to the power of 1 divided by 2 to the power of 999 is simply 2 to the power of 1. Now I have this minus 2 to the power of 999 divided by 2 to the power of 999 is 1. 2 to the power of 1 is 2. So now I have 2 minus 1, which is equal to 1. So I have 2 to the power of 999 times 1, which is simply equal to 2 to the power of 999. Now, another way of doing this so I first start with 2 to the power of 1000 minus 2 to the power of 999. Now this time, I'm going to rewrite 999 as 1000 minus 1. So now I have 2 to the power of 1000 minus 2 to the power of 1000 minus 1. And now that's the same thing as 2 to the power of 1000 minus 2 to the power of 1000 plus negative 1, which is equal to 2 to the power of 1000 minus 2 to the power of 1000 times 2 to the power of negative 1. Now if I factor out 2 to the power of 1000, I get 2 to the power of 1000 times 1 minus 2 to the power of negative 1. This is equal to 2 to the power of 1000 times 1 minus 1/2, which is equal to 1/2. So I have 2 to the power of 1000 times 1/2, which is the same thing as 2 to the power of negative 1. So now I have 2 to the power of 1000 times 2 to the power of negative 1, which is equal to 2 to the power of 1000 plus negative 1, which is equal to 2 to the power of 999. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3x to the power of x is equal to 3 to the power of 3 to the power of 3. Now, what I'm first going to do is I'm going to take the power of 3 on both sides. So now we have 3x to the power of x to the power of 3 is equal to 3 to the power of 3 to the power of 3 to the power of 3. And if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3x to the power of x to the power of 3, well, this is equal to 3x to the power of x times 3, which is simply just 3x. And this is equal to, now, a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. Because essentially, both of these are equal to a to the power of m times n. So they can change places. So right here, we have 3 to the power of 3 to the power of 3 to the power of 3. And this can be written as 3 to the power of 3 to the power of 3 to the power of 3. And now, if we have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. As you can see here, 3x to the power of 3x, both of these are the same. The exponent and the base are the same. And same with here, 3 to the power of 3 to the power of 3 to the power of 3. The exponents here are the same. Meaning, this would equal 3x is equal to 3 to the power of 3. Now, we can either do this in two ways. Our first way is doing 3 to the power of 3. Well, 3 to the power of 3 is 27, so we get 3x is equal to 27, and if we divide both sides by 3, this cancels out, and we get x is equal to 27 divided by 3 is 9. Now our second way is 3x is equal to 3 to the power of 3. Second way is just simply dividing 3 at the start, and 3 to the power of 3 divided by 3, well, this is 3 to the power of 1, and if we have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of 3 over 3 to the power of 1, this is equal to 3 to the power of 3 minus 1, which is simply just 3 squared. And for our left hand, these cancel out, and we get x is equal to 3 squared, and 3 squared is 9. So we get x is equal to 9. So that's our second way.